Number 1. Graph each set of ordered pairs. Use words to describe the pattern shown in the graph. So first, we're matching these graphs with the coordinates in just A. So looking at the coordinates, they are going up by 1 in x value, 0 to 1 to 2 to 3, and the y values are going up by 1. Since it's constant, it's going to be linear. That means our graph is going to be a line, which means it's not going to be B or C. It's going to either be A or D. Let's make this a little larger. So we have 0, 0, 1, 1, 2, 2. Okay, so this tells me it has to be A. Now, which statement best describes the pattern? So when x increases by 1, 0, 1, 2, 3, y also increases by 1 from 0 to 1 to 2 to 3. So that means it's going to be C. When x increases by 1, y increases by 1. Now we're going to do the same thing for B. We have 0, 10, 1, 9, 2, 8, 3, 7, and 4 and 6. So as x's are increasing, y's are decreasing. So we know it's not going to be A because it's going down by a constant amount. It's going to be linear. Let's start with B. So we have 0, 14, which automatically tells me it's not going to be B. Let's check C. Okay, so we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so it's not going to be C. So that means it's going to be D. It starts at 0 and goes up to 10. And it's decreasing, so that's the graph for B. Now, as x increases by 1, the y is decreasing by 1. So B for the second one. Now for C, every x value stays the same. That means it's not going to be C. A, every y value is the same, so it's not going to be A. It's going to either be B or D. So you have 0, 2, 4, 6, and 8. So it's increasing by 2 each time. D is not increasing by 2 each time because we have these two right here. So you're going to choose B for this one. So which statement below best describes the pattern? Well, we said x stays the same and y increases by 2. So x is always 3, y is increasing by 2. Okay, number 2. For this one, in the diagram below, what is the relationship between the number of triangles and the perimeter of the figure they form? Represent this relationship using a table, words, an equation, and a graph. Let x equal the number of triangles. Let y equal the perimeter. So 4 plus 4 is 8, plus 5 is 13. Now, ordered pair, you're going to put x and y in parentheses. So parenthesis 1, comma, 13, parenthesis. Number 2, second triangle, 4 plus 4 is 8, 5 and 5 is 10, 10 plus 8 is 18. Now parenthesis 2, comma, 18, parenthesis. The third one, 5, 10, 15, plus 4 and 4 is 8, so you have 15 and 8, which would be 23. Good, so now we are representing the relationship using words. It says multiply the number of triangles in each figure by. That's always going to be in the terms of our triangle, the top and bottom sides being added up. So if you look at the first triangle, the bottom side is just 5. That's what we're multiplying by. And it gives you the total length of the top and bottom sides. To find the number you add, it says to add for the total length. That will be the left and right sides in terms of our triangles. So look at triangle 1, left and right will be 8. Second triangle, left and right is 8. Third triangle, left and right is 8. So we're adding 8 for the total length of the left and right sides of the combined figure to get the entire perimeter. Now, to represent this using an equation, we're going to have x as our variable, and we know x is being multiplied, so the number we multiply is 5, and then we add 8. So now our graph, it's going to be a line, so we know it's not going to be C. It's increasing, so it's not going to be D. So it's going to either be A or B. Now, what's going to be my X and Y is what's making A or B different from each other. So look at our table. We have X being the number of triangles, the perimeter being Y. Now, that means 1, 2, and 3 is going to be X, Y is going to go up to 32 to accommodate my perimeter. So B is going to be my graph. And that's number 2. Table to the right, represent the relationship using words, an equation, and a graph. Then determine whether the relationship is a linear function. So looking at the x's, it is increasing by one value to the next. Looking at the y's, you're increasing by 8 on each one. Now when you're increasing by 8 on each one, that means my rate of change is going to be 8. It's linear. So what you do to that rate of change is multiply it to x. So 8 times the value of x. Only one of these involves 8 times the value of x, and that is d. Now, so typing in the equation, we have 8x. Now, say I pick one of these x's. Let's pick, 1. So 8 times 1 is 8. Now, what do I add or subtract to 8 to get 3? I would subtract 5. So that means minus 5 will go in the second part of my equation. Now, picking my graph. My graph is increasing, so it's not going to be B. And if you look at C, it's not linear. So, and A is not linear either. So your answer has to be D for that part. And is it linear? Yes, it is, because it has a constant rate of change. All right, number 5. So represent the relationship shown in the table using words, an equation, and a graph. Then determine whether the relationship is a linear function. So looking at our table, we have mountain climbing. So x is the number of hours. So every hour, our elevation is increasing. And it is increasing each amount by 93 feet. You determine that by subtracting each pair, and they're all 93 feet apart. 0 is the starting point. So we're starting at 1,109 feet. So starting from a height of that means either A or D. We are gaining 93 feet, so that would be D. So representing that in an equation, what we're gaining each hour will be my rate of change, so 93x, and my starting point will be 1,109, so plus 1,109 for my equation. Now for my graph, I'm not starting at 0, 0, so that means C is not going to be my answer. I am increasing, not decreasing, so it's not going to be B. is linear, so it's not going to be A. It has to be D. Which answers my next question. It is linear. Okay, so you can make 3 gallons of liquid fertilizer by mixing 10 teaspoons of powdered fertilizer with water. Represent the relation between the teaspoons of powder used and the gallons of fertilizer made using a table, an equation, and a graph. Is the amount of fertilizer made a function of the amount of powder used? Now the input is the teaspoons, that's what we're adding in, and what we're getting is a certain number of gallons. So input is X, output is Y, so that means C is going to be our table. Now turning that into an equation. So let's take a closer look on finding rate of change. Okay, so to find rate of change, we notice that going from 0 to 10, 10 to 20, 20 to 30, we are increasing by 10. That's what's called the change of X. Now we know for the Y's we're increasing by 3. So 3 is the change of Y. So now rate of change is change of Y over change of X. So we write change of Y first, which is 3, over top of 10, which is change of X. So my rate of change is 3 over 10. Write this as an equation. My rate of change, we said, is 3 over 10. So we have Y equals 3 over 10x. Now my starting point at 0 for x is going to be 0 for y. So we don't put anything there because you don't have to put plus 0. So my equation is simply going to be y equals 3 over 10x. So let's go back and type it in. So 3 over 10x. Now my graph, now our graph is increasing, so it's not going to be A. So it's between B and C. Now, our first point would be 0, 0. They both have 0, 0. The next one is 10, 3. So x being 10, looking at C, this is not where x is 10. But we know x is 10 here because it's halfway between 0 and 20. That means it has to be B. So, is the amount of fertilizer made a function of the amount of powder used? We will say yes. And that's number 6.